Okay, dear students, today by using some videos over here, the first chapter of your chemistry class 11 science, which is called some basic concepts of chemistry. In this chapter, when I had sent you the notes of this chapter, I had over there mentioned various laws of conservation of mass, law of multiple proportion, law of reciprocal proportion, and so on. So by using 3 or 4 parts of a video, I'll be teaching you how to do problems based on this chapter. So here is problem number 1. Please copy this problem in your exercise copy, and then I'll teach you how to do it. This is a problem based on law of conservation of mass. 6.9 gram of potassium chlorate on heating gives the residue of 4.96 gram. Calculate the mass of oxygen released using law of conservation of mass. This is a problem based on law of conservation of mass. Now, to be able to do this sum, this numerical, this problem, by reading the question, you must be able to write or frame the chemical equation yourself. Potassium chlorate, the formula is already given in the question over here. KClO3. When potassium chlorate is heated strongly, it undergoes a decomposition reaction to produce the residue as potassium chloride, and the gas which is liberated is oxygen gas. This gas escapes in the atmosphere, whereas the residue is potassium chloride. After writing the chemical equation, you make sure that the equation is balanced. So the equation must be balanced. You put 2 in the front over here. Now you check. Potassium is 2, chlorine is 2, oxygen is 6. Okay, so you have to balance oxygen the other side. So we put 3 over here. Now the equation is balanced. Now go back to the question. 6.9 gram of potassium chlorate on heating gives a residue. This is the residue. Potassium chloride is the residue. Residue is 4.96 gram. So I write over here 6.9 gram of potassium chlorate. It is giving 4.96 gram of the residue, which is potassium chloride. Now we know, according to the law of conservation of mass, the total mass of the reactants should be equal to the total mass of the products. So here, if you write according to the law of conservation of mass, we know that the total mass of the reactant should be equal to total mass of the products. So that is what we are going to do now. So therefore 6.9 gram of potassium chlorate should be equal to 4.96 gram plus, we don't know the mass of oxygen, so I write X over here. So 4.96 gram plus X. Now over here, let us find the value of X. The value of X will come to 6.9 minus 4.96. That comes to, subtract it, you will get the answer. You will get roughly 1.94 gram. 1.94 gram. This 1.94 gram, it is the mass of oxygen. So now we have got 1.94 gram over here. Now since the value of X is 1.94 gram, if you add 4.96 plus 1.94, it will come to how much? It will come to 6.9 gram. So the total mass of the reactant over here, it is equal to total mass of the product. This is one way of doing the problem. Okay. Now, thus we can say that the law of, over here, if the law of conservation of mass holds correct, then only the mass of oxygen is 1.94 gram. Okay, so we have done the first problem based on law of conservation of mass. Now I will do another problem based on the other law which I have told you earlier in my notes over there. Okay, so here the second law which I am trying to tell you is law of multiple proportion. Now when I am speaking law of multiple proportion, please revise the statement for the law of multiple proportion. Okay, now according to the law of multiple proportion, which I have told you already earlier. Okay, now as I was talking about the law of multiple proportion, let me first give you the statement of the law, which I have already given you in the assignment notes over there, long time back. Now, according to the law of multiple proportion, please listen very carefully. A chemical compound, if two elements combine to form more than one compound, if two elements combine to form more than one compound, the different masses of one element which combine with the same mass of the other element are in simple ratio to one another. Again, I repeat this statement for the law of multiple proportion. If two elements combine to form more than one compound, if there are two elements which combine to form more than one compound, okay, then the different masses of one element which combine with the same mass of the other element are in simple ratio. They are in a simple ratio to one another. That is very important to understand over here. Okay, now look at the question. Copy the question. A metal X forms two oxides in the following composition as given on the board over there. A metal X. Now, if you look at oxide A, in oxide A, mass percentage of X is 78.77%. In the same oxide A, the mass percentage of oxygen is 21.23%. So, now oxide A, if you add the mass percentage of X and mass percentage of oxygen, it should be 100%. And in oxide B, the mass percentage of X is 88.12 and the mass percentage of oxygen is 11.18%. Now the question says, show that the above data illustrate the law of multiple proportion. So by using the concept of law of multiple proportion, we have to show whether this data is obeying the law of multiple proportion or not. Please copy the question. I am waiting for you to copy the question for some time. Okay, now you must have copied the question. So this is how you can solve the problem and illustrate the law of multiple proportion for this given data. So what you do is make two columns over here. In compound A, first column, in compound B, compound A, compound B, or oxide A or oxide B. Now under compound A, you see 21.23 parts of oxygen. 21.23 parts of oxygen combined with 78.77 parts of X. So I write it down. Similarly, in the second column under compound B, I write down 11.18 parts of oxygen combined with 88.12 parts of X. So now I must make the part of oxygen same for both these compounds. So what will I do? Over here below this I write, therefore one part of oxygen will combine with unitary method. 21.23 parts of oxygen combines with 78.77 parts of X. Therefore, one part of oxygen will combine with 1 multiplied by 78.77 divided by 21.23. Simplify this. 1 multiplied by 78.77 divided by 21.23. It will give me 3.7 parts of X. So I have got over here 3.7 parts of X. That is, if I take one part of oxygen, this one part of oxygen will combine with 3.7 parts of X. Now I go to the second column. In compound B, 11.88 parts of oxygen combines with 88.12 parts of X. Therefore, I write down 1 part of oxygen will combine with 1 multiplied by 88.12 divided by 11.88. So this will again give me simplified 88.12 divided by 11.88. This is giving 7.4 parts. 7.4 parts of X. So I have got a very important number over here, another important number over here. Now, according to the law of multiple proportion, which I have already stated in the beginning over here, and you must have already learned it properly. According to the law of multiple proportion, we know that if two elements combine to form more than one compound, the different masses of one element which combine with the same mass of the other element, same mass. Over here, the mass of oxygen is same. So, if two elements combine to form more than one compound, the different masses of one element which combine with the same mass of the other element are in simple ratio. They are in simple ratio with one another. So, now we can write one final statement over here. Thus the mass of compound X in compound A and B. So here what I can do is, I can write a final statement. Thus the mass of compound over here, thus the mass of X, thus the mass of X in compound A and B, thus the mass of X in compound A and B which combine with a fixed mass of what? Mass of oxygen. Fixed mass of oxygen. The mass of oxygen, I made it fixed. One part of oxygen here, one part of oxygen here. So now we can get the ratio very easily over here. Thus the mass of X in compound A and B which combine with a fixed mass of oxygen are in the ratio. Look at the ratio. It will come 3.7. This 3.7 is to, over there it is 7.4. Look at this. Try to simplify this ratio. So 3.7 is to 7.4 can also be written as 1:2. 1:2. It is a simple, over there it is a ratio 1:2. This is a simple ratio and illustrates the law of multiple proportion. So this ratio, it is a simple ratio. This is a simple ratio and illustrates the law of multiple proportion. So this is how we solve any problem based on multiple proportion. Now this law of multiple proportion was proposed by Dalton. So you have to remember that, and you must learn the statement for the law of multiple proportion. It is very, very important. Now again I repeat everything once more. A metal X forms two oxides in the following composition. Okay, mass percentage of X in oxide A is 78.77. Mass percentage of oxygen in compound A is 21.23, and in oxide B percentage of X is 88.12, percentage of oxygen is 11.18. So whenever you do problem based on multiple proportion, make this column, make these two columns, because we have to use two compounds over here. So in compound A, by using the above data, 21.23 parts of oxygen combined with 78.77 parts of X. Therefore, one part of oxygen will combine with 1 into 78.77 divided by 21.23, that is coming 3.7 parts of X. And the other side 11.88, it is not 88, it is 11.18 parts of oxygen, 11.18 parts of oxygen combined with 88.12 parts of X. Therefore, one part of oxygen will combine with 1 into 88.12 divided by 11.18. So that will come to 7.4 parts of X. In compound A, one part of oxygen combines with 3.7 parts of X. In compound B, one part of oxygen will combine with 7.4 parts of X. The part of oxygen is same. The amount of oxygen is same for both the compounds. Now, thus the mass of X, mass of this compound X, which combines with the fixed mass of oxygen, can be brought down in a ratio like this. This 3.7 is to 7.4, which is a simple ratio. It is coming to 1 is to 2. This is a simple ratio, and the above data illustrate the law of multiple proportion. So now, this was the second problem based on this chapter, law of multiple proportion. Now, let us go to the next problem. Now, this is the third sum. This is also a problem based from multiple proportion concept, using the same concept, problem, what you call multiple proportions. Now look at the question very carefully, copy it down. Okay, two oxides of a metal. There are two oxides of a metal containing 27.6% and 30% oxygen respectively. The percentage of the metal is not given in the question, but that can be calculated. If the formula of the first oxide is M3O4, find the formula of the second oxide. So here also we have to use the concept of law of multiple proportions. So this sum also, what you can do is make two columns. In the first oxide, metal 72.4 parts. How? Because the percentage of oxygen is given 27.6 parts of oxygen is there in the first oxide. So 100 minus 27.6 will give me 72.4 over here. So to get the percentage of metal in the first oxide, so 100 minus 27.6, so that will give me 72.4 parts. Now the formula of the first oxide is given as M3O4. It is given over here. If the formula of the first oxide is M3O4, find the formula of the second oxide. So here what you have to do, using whatever data is given, I write 72.4 parts of metal. This 72.4 parts of metal, look at the formula. How many atoms of metal? 3 atoms of metal. And this 27.6 parts of oxygen, how many atoms? Look in the formula, 4 atoms of oxygen. So stop over here. Then you go to the next column over here. In the second oxide, we know oxygen is given 30%, no? So write it as 30 parts. If oxygen is 30 parts, to find the parts of metal, we can do 100 minus 30. So that will give me 70 parts. Now, from here, use this now. 72.4 parts of metal, it is given, we have seen from the formula, 3 atoms of metal. So I write down 3 atoms of metal. Therefore, this 70 parts of metal will be equal to 70 multiplied by 3 divided by 72.4. That will give me 2.90 atoms of metal in the second oxide. Again, 27.6, since 27.6 parts of oxygen, from here, since 27.6 parts of oxygen is, how many atoms of oxygen? 4 atoms. So I write down, since 27.6 parts of oxygen is 4 atoms of oxygen, therefore in the second oxide, 30 parts of oxygen is 30 into 4 divided by 27.6, that will give me 4.348 atoms of oxygen. So now the ratio of metal is to oxygen. The ratio of metal is to oxygen can be worked out. It comes to how much? Over here, the ratio of metal is to oxygen. Metal is 2.90. Over here, oxygen is 4.348. So I will write it down over here. 2.90 is to 4.348. This is the metal, this is the oxygen. So this is the ratio of the metal is to oxygen, which we have obtained over here. Now, upon simplification, this can be written as or or 1 is to, it will come roughly 1 is to 1.5. 1 is to 1.15. Just check. 1 is to, not 1.15, 1 is to 1.5 over here. 1 is to 1.5. So 2.90 is to 4.348 will come 1 is to 1.5. Or this can be, this is 1.5. You cannot round it to 2. You can multiply this 1.5 by 2. If you multiply here 2, you also multiply by 2. So that will come to 2 is to 1.5 into 2 will become 3. So this is the ratio. This is the ratio of the metal and the oxygen in the second oxide. So hence we can say hence the formula. Hence the formula of the second oxide. Second oxide is, you can write down M2O3. This is the answer. So this is how you are going to do the second sum, which is a problem based on the concept of law of multiple proportions. So we have done this. Therefore the formula of the second oxide is M2O3. I hope you have copied the solution. Okay. Now this is a problem which is based on law of multiple proportions. Look at the solution very carefully. Okay. There are two oxides of a metal containing 27.6% and 30% oxygen respectively. If the formula of the first oxide is given M3O4, using the law of multiple proportion, find the formula of second oxide. So what I have done is divided into two parts, two columns over here. In the first oxide, metal 72.4 parts. How? 100 minus 27.6. In the second oxide, metal 70 parts, 100 minus 30. It is given away 30. Okay. So now using the first part formula of the first oxide is M3O4, which is given. 72.4 parts of metal. How many atoms of metal? 3 atoms. So I write it down. And 27.6 parts of oxygen is 4 atoms of the oxygen. So using these two lines over here, I go and do the working over here in the second oxide column. Since 72.4 parts of metal is 3 atoms of metal, therefore 70 parts of the metal in the second oxide will be 70. This 70 multiplied by 3 divided by 72.4, that will give me 2.90 atoms of the metal in the second oxide. Again, since 27.6 parts of oxygen is 4 atoms of oxygen, therefore 30 parts, this 30 parts of oxygen will be equal to 30 multiplied by 4 divided by 27.6, that is coming to 4.348 atoms of oxygen. Now in the second oxide, we have got the number of atoms of metal and the number of atoms of oxygen. So using these two data, we write a sentence. The ratio of metal is to oxygen in the second oxide is 2.90 is to 4.348. Upon simplification, it comes roughly 1 is to 1.5. Now this 1.5 cannot be rounded off. It can be multiplied by 2. So 1.5 into 2 gives me 3. And here 1 into 2 will give me 2. So I am getting the ratio of metal is to oxygen as 2 is to 3. Okay. After all rounding off. Hence the formula of the second oxide is M2O3. So this is a problem which is based on law of multiple proportion. Now we move further. Now we have over here the next sum, which is a problem based on law of reciprocal proportions. Now let me just tell you the statement for the law of reciprocal proportions. According to this law, two elements A and B would combine in the same ratio of masses or in simple multiple ratio of masses in which they separately combine with a fixed mass of the third element, C. If you take two elements A and B which are combining in the same ratio of masses or in simple multiple ratio of masses in which they combine separately with a fixed mass of the third element. So that was the statement for the law of reciprocal proportions. You must have learned, you must have gone through the law from the notes which I have given you in the school website and in the WhatsApp group. Now let me read this question very carefully. There are three compounds: carbon dioxide, carbon disulfide and sulfur dioxide. Basically what I mean to say is there are three elements: carbon, sulfur and oxygen. Carbon, sulfur and oxygen forming three compounds. The first one is carbon dioxide, the second one is carbon disulfide and third one is sulfur dioxide. And in these three compounds, the percentage of carbon, it is 27.27%, the first one. In carbon disulfide, the percentage of sulfur is 84.21%. This illustrative diagram is not a part of the question. I have drawn this diagram to explain you how to solve this and how to understand this question. In carbon disulfide, the percentage of sulfur is 84.21%, and in the third compound, that is sulfur dioxide, the percentage of oxygen is 50%. So, now using this data, we have to show that this results 27.27, 84.21 and 50%, they illustrate the law of reciprocal proportion. Basically, there are three elements: carbon, oxygen and sulfur. Carbon is combining with oxygen to form carbon dioxide over here. It is forming carbon dioxide. Carbon is combining with sulfur to form carbon disulfide. And over here, sulfur is combining with oxygen to form sulfur dioxide. Okay. So these are the three compounds which are combining with each other to form three different compounds. And moreover, in carbon dioxide, the percentage of carbon is given. In carbon disulfide, the percentage of sulfur is given. In sulfur dioxide, the percentage of oxygen is given. So knowing these percentages, in the compounds carbon dioxide, sulfur and oxygen, it is possible to find the percentage of the other element which is already over there. Let us calculate it. You calculate. I am waiting for your answer now. Now you must have copied the question. Okay. Now, let us first look at these two compounds, carbon dioxide and carbon disulfide. In carbon dioxide, what is given? Percentage of carbon is 27.27. In carbon disulfide, what is given? Percentage of sulfur is given 84.21. So, to get the percentage of carbon and over here oxygen, we can subtract it from 100. So now come back over here. For carbon dioxide, carbon is 27.27 and oxygen is 72.73. Therefore, 1 gram of carbon will react with 1 multiplied by 72.73 divided by 27.27. It is coming 2.67 gram of oxygen. Similarly, for carbon disulfide, carbon is 15.79. And sulfur is 84.21. It is given. Therefore, 1 gram of carbon reacts with 1 into 84.21 divided by 15.79. It will give us 5.33 gram of sulfur. So we have got the number of grams or percentage of oxygen and the percentage or number of grams of sulfur. So we can give this into a ratio. Ratio of oxygen is to sulfur. This oxygen is to sulfur. In these two compounds, it will come 2.67 is to 5.33. That will be 1 is to 2. Ratio of oxygen is to sulfur in the third compound, that is sulfur dioxide, will be, if you look at it, it is 50%. So it is 1 is to 1. That is a simple ratio. So now this was a problem based on the law of reciprocal proportion. So as I have already stated you the law in the very beginning, stating that according to the law of reciprocal proportion, if there are two elements A and B would combine in the same ratio of masses or in simple multiple ratio of masses in which they separately combine with the fixed mass of the third element C. So here in compound carbon dioxide and carbon disulfide, the ratio in which oxygen combines with carbon and the ratio in which sulfur combines with carbon, it is, we have got how much? 1 is to 2. But the third compound is sulfur dioxide. In the third compound, that is sulfur dioxide, sulfur is from here, oxygen is from here. So the ratio is coming simple ratio 1 is to 1. But for this two, it is coming a multiple ratio, that is 1 is to 2. So this was the problem based on law of reciprocal proportion. So now, my dear students, I want you all to go through these 4 sums very nicely. This is the part 1 of this chapter, some basic concepts of chemistry. Okay, I have explained to you different types of problems based on conservation of mass, problem based on multiple proportion, problem based on reciprocal proportions only. In my next video, I'll be doing some more problems, that is problem based on gaseous volumes, Avogadro's hypothesis, empirical and molecular formula from this chapter. And I'll be teaching you about the calculations, how to do calculation based on molarity, molality, normality, and so on. Thank you for now. Have a nice day.